Hello, my good friends on the internet. All right, so we have a revision. Revision sessions. Revision. Yeah. Today is the weekend. Yesterday I started doing some revision on the questions I've solved before, and I'm trying to change my approach to studying. I think the best way, like I said yesterday, is to solve the same question multiple times and enough so that the understanding is just second nature and you just simply know what to do when you even y- just by looking at the question you already know the steps to take, right? Because you solved similar questions before. So and that's exactly what I'm going to do today. I'll be revisiting some questions I solved before, and also I will make some notes. I actually brought my my special tool for taking notes. So we'll be using. Okay, I think I must have opened a lot of tabs, but let's see. Yes, Obsidian. I'll be using Obsidian to write notes, and to it's just a markdown tool. Yes, for taking notes. It's free, and I'll also be sharing these notes with you guys and explaining what I'm doing in every question I solve, right? So I'll create a folder for each one of them. So this will be um, a sliding window. So I'm going to, I can change in between. I can switch from any type of algorithm. So I'll do sliding window from now. Sliding window like this, and I'll create another folder for let's see. I'm not sure if you can see this, but let me see if I can increase my window. Okay, yes, sorry, I can increase this window. So this will be a sliding window. Let me close this part. This here will be two pointers, two pointers, two pointers like this. And what else? We can have arrays. Arrays will have strings, strings like this. We'll have uh hold on, my internet is still really okay. We can have binary search. We'll have what else did I study? Linked list, my favorite. Oh my god, I love linked lists. Linked lists, right? Here are the algorithms I've studied so far. We have queues. Um, what else do we have? What else? This I'll call this. I can call this intro. Okay, DSA, DSA intro revision. Okay, DSA revision. Let me call this revision like this. All right. So yeah, I mean this is a Markdown tool. We can write in Markdown here. Anyways, so for now we'll just keep it like this. And for every question, I'll create a file. I can also have like similar questions grouped together, explaining how similar they are and the steps to solving some questions, right? So let's say I create a folder, I create a file here, new note. This note will be called let's see I'll say sliding window algorithm. algorithm trick, or I don't want to call it a trick, but like let's say um uh, what should I call this? Okay, let's just leave it as sliding algorithm, sliding window algorithm. So the sliding window algorithm is really, um, you know, has to do with sub a subset of a particular iterable data type. Let's say strings and arrays or lists in Python. So usually when we are asked to find a subset of something, right, or a substring, a subarray, or anything that deals with a contained version of a um, larger amount of thing, right? It's usually relating to data. Um, it's usually related to sliding window algorithm. So here's what I'll say. I'll say you know I'll just put when to use when. Let's make this a bit. I think if you do this, yes, and I can just do something like this. Okay, you know what? I wanted to make this. Yes, so I'll say when this is too big, so I'll just reduce it again one more time. Yep. Okay, another one. Okay, that's enough. So when to use when to use. Okay, so I'll just put a note here. I'll say if the question is you know requesting to return a subset, right, of a uh, larger iterable data type, and by iterable I mean either string or an array. So when the question um when return a subset, right, a subset, or not just returning, like working with a subset of a return, or um work with a subset of a larger iterable. So I'll just put this like this, iterable. So iterable like this. Say that is sub array, uh, sub array or substring or substring. Yeah. Then there is a chance. Okay, then we can consider. Then we can consider using the sliding window algorithm. I don't know why I'm tapping so slow. Sliding window algorithm. Okay, so I don't think this is in the dictionary yet, but let's add it. So, if the question asks us to return or work with a subset of a larger iterable, right? Then, and by larger iterable, I mean sub array or substring, then we can consider using the sliding window algorithm. So, here are some few examples. um I don't know why this is like this. I was thinking to use something like a, you know what, I'll properly format this. I don't want to use something like this. So let's see. I want to make this a format. No, 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 no. I've forgotten how to do this. But anyways, quote. Yes, exactly. So that's what I wanted. So then we can use a sliding window algorithm in that case, right? So let's go ahead. So here, ah, how about I type it like this? Here are a few examples, right? Now I want to write all these notes down and the trick to solving all these questions, because it will help us, remember what to do in certain cases, right? So here are a few examples. Um, so I'll underline this. Can I underline? Yes. You cannot underline, but anyways, let's just pick this. Let's make this italic. So I will solve, like I said, I'm usually going back to the questions I solved previously. So let's take a look at some questions here. So we'll look at the contains duplicates question, right? Now, this is probably not relating to a sliding window problem, but let's see. It's a question I actually, solved previously, and this time around, I'm revising. I'm revisiting every question I solved previously and solving them again just to, build that muscle memory. Otherwise, if you don't repeat stuff, you'll forget, right? So let's see. We have contains duplicate, and given an integer array norms, right? Return true if any value appears at least twice in the array, and return false if every element is distinct. Okay, so there are a few ways we can do this, right? We can, let's say we come here. So we want to return true if any element in the array appears at least twice. So let's see what we can do. So I can say, given an integer array, blah blah blah. So I've read that. Return true if any value in the array appears at least twice, right? So meaning if there's any duplication of a particular value in the array, then we can return true. Otherwise, if every element in the array is distinct, then we return false. Now there are a few ways we can do this, and one of the first methods to use is actually by, uh, first of all, taking every unique value in the array, right? So basically, we set them in a set. So I'll create. This is 1 2 3 1. So say here's our first example. The input will be 1 2 3 and then 1, right? Uh, so 1 2 3 1, and then here is what we need to do. We want to verify if any integer in this array appears at least twice. Now we can see it with our own eyes that, okay, we have one here, we have one here, and we also have one here, which is really good, right? So we know there's a duplicate. But how do we do this in terms of coding? How do we program our solution to always detect if there is at least one integer in the array that was, that appears twice, right? I can see there's a message in the chat. Um, TT said, I will join. Okay, cool. I'm not sure, but you're welcome. You're welcome to the stream. All right, so let me close the chat for now because I'm very tempted to respond to messages while I'm explaining stuff, which can seem like a bit of deviation, but I'll always respond to all messages by the end of each explanation I put out here. So, anyways, let's continue. Now we have one. This is our input array, and we want to find if there is at least one integer in the array that has a duplicate. So first of all, one thing to note here is that we can create a unique version of every integer in the array, right? And then iterate through the array to see if that item is at least in that unique version, right? So here's what I mean. If we have a unique version of this array, will be 1, 2, 3, right? Now, if we iterate through this 1, 2, 3 here, right? I mean, if we iterate through this part, we can find out if each element here appears in this array, and if we already seen it before, right? Or another way we can do this is to basically we can create a map of every element. It's still like the way we did unique item here, but if we create a map of every element in the array, right, it's still like a set. Like I said, we can have each element with their corresponding amount of time or frequency they appeared in the array. So by frequency is simply creating a dictionary with the item, right? In this case, this will be 1. And then how many times have we seen 1 so far? We've seen 1 once, right? So we add 1 here, and then we move on to the next number, which is 2. Then we add 2 once. 3, we have 3. How many times have we seen 3? We've seen 3 just once. And then we have 1 again. Now this time around, we can't add this 1 at this position. We can't add this 1 here like this, 1, 1. Because dictionary have a way of storing keys to be unique, right? So if there is a value already in the dictionary, and you want to insert that value back to the dictionary again, or you want to introduce that same value to the dictionary, it will simply override whatever was there. So in this case, while we are building up this dictionary, we can actually check if the value already exists in the dictionary. So during the build up phase, we can keep checking if we already have that key in the dictionary. When we see that we have the key in the dictionary, it means that value is duplicated in our original input, right? And then we can stop the iteration at that point. It means we have at least one duplicate in the array, right? Which is our input here. Otherwise, we'll keep adding the values, like I said, to the dictionary step by step. So that's all we need to do. And for us to program this, it's going to be this way. So I'll say let's write out the code for that. So I'll come here. Let me open my playground. Okay, I started doing something like revision, right? Is this revision? Repetition. This question is arrays, right? So can say this is not really repetition, but I'll call this, okay, let me leave it as repetition, because so let's see, repetition what? Okay, rep 1. Okay, that's good. Let's create a Python file. This will be contains duplicate 1, right? Contains duplicate 1. Okay, so lit, what number of lit code is this? 217. Okay, so lit dash 217 dash contains dash duplicate dash repetition 1. So this is the first time I'm repeating this question. Always repeat the same question you solved previously. It doesn't take anything away from you. It only enforces, the ideas that you had previously, or the way you solved the question previously, so that you don't forget. So no matter how easy the question is, repeat it. That's what I've been telling myself, and I've started doing that now. So we have this boilerplate code. I'll just copy this, paste it here. So let's do this. I will import this name here, and then we can, first of all, there are two ways we can do this. Like I said, we can use sets and add items to the set, the way respectively, just by adding each item to the set like this. So let's do that first. So we can say, I'll call this items, or let's say int set. I'll call this int set, and this is going to be a set, right? And then we'll iterate through the array. Say for I in range len of nums, right? We can say, if nums is in the array. So okay, if nums at I, you know what, I don't even need the index here. I can just say for num in nums, right? I can say if num in int set, if the num is in the int set, okay, if num not in int set, right, then we add it to the set. So int set dot add num, right? Else it means we've seen a duplicate, so we'll just say return true. Otherwise, this iteration will end and will return false. So like this. Okay, we can test this out here and see what we get. So we'll say, solution. Let's create. Okay, you know what? Let's bring in a new convention. So I'll call this my solution, and I'll set it to the solution class, instantiate it, and let's print our solution here. Print my solution dot contains duplicate. So we have 1 2 3 1, right? And let's see. So this should be true, right? So we have true printed in the console. So this is how we can find if a number contains a duplicate. This is one of the ways. Another way you can do this is by using a normal dictionary, and then you add the integers as the keys of that dictionary, and maybe the index at which, or the count. So for frequency's sake, you want to count how many of that items is already in the dictionary, so that when you increment it, you can then check, okay, is the current you know what, let me not just talk too much, let me just write the code for that. I can still do this in another way. I'll just comment this out, or let's just comment this out, and I'll copy this part. Since, okay, you know what, I'll leave this here, and then I'll create a new function, of a new method of this class, right? And then instead of I'll call this contain duplicate 2, or approach 2. Okay, let me call this second approach. Okay, So here is the second approach. So we can say I'll call this my dictionary, and this will just be an empty dictionary, right? So we'll begin to add items to the dictionary if they are not already in the dictionary. So let's iterate through the dictionary. So say if nums um so since we want to, well, okay, so sorry, for num in nums, right? Can say if the number is not already in the dictionary, we can add it. Else, we can increment its frequency. So say if num not in my dictionary, right? We can just do my dictionary at num to be equal to 1. So far we've seen it once, but the next time, if it's already there, um we can just say num, right? No, sorry, my dictionary at num plus equal 1. So we increment it by 1, and then we can check if my dictionary at num, right, is superior to 1, then we return true. I mean, this is more sorry, true. This involves a little bit of steps, but um you know what, it's not bad. So we can return, sorry, yeah, we can return false here. Okay, so false. All right, so let's see if we can do this. Duplicate second approach. So when I run this should return. Okay, now we are getting true instead of false, right? Okay, so what's happening here? Oh, so sorry. We're supposed to get true. Okay, both of them work, right? The answer here is true because there's one here and one here. I want to return true if there is a duplicate. So let's copy this. Now the time complexity for this solution is O of n because we are iterating for every number in the nums array. So um, no big deal at all in this case. Yeah. Okay, so let's see how this will play out. I'll just bring this one here and let's run it. Now there might be some edge cases that we'll probably need to look into, but we'll do that in a bit. Let's see. Okay, the edge cases have been passed, so let's submit this and see what we have. Hello everyone. Nice to have you here in the stream. You're welcome. You're welcome. Okay, so that's it for this question. Now, the reason why I solved this question here is to give a head start, right, or a foundation upon which we will solve the next question. Now, the next question is contains duplicates 2, and there is 3 too, which is a hard question, but anyways, we'll look into that later. Contains duplicate 2, given an integer array nums and an integer k, return true if there are two distinct indexes I and j such that nums at I is equal to nums at j, and nums at the absolute value of their difference between I and j is less or equal to k. So return true or false. Okay, so another boolean expression. So what do we do in this case? Want to return true or false, right? If sorry, if there are two distinct indices. So two numbers are separate indices in this array, such that the number at I is exactly the same as the number at j, and the absolute value of their difference is less or equal to k. So this is quite you know so first of all, they are asking us to do two things. We want to first of all find out if there are any duplicates, and those duplicates have to be in separate positions. Now, in separate positions, I mean distinct indices, right? And also the difference, the absolute value of their difference, that is I minus j, is less or equal to k. Now, k is a constant that will be given to us, but we'll have to find out. So, what do we do in this case? We can still use the same foundations that we used previously. We can first of all you find out, right? So one way we can do this is by using this method here. We can find out, we can add numbers into the dictionary, right? Just to keep track of the unique ones. And once we get a duplicate, right, then we'll find out at that particular index, and the index at which we found the first occurrence of that item or that integer, we'll find the difference between those two, right? So in this case, we'll store the integer and its index or index, and then we'll find out if the difference, the absolute value of their difference, is less or equal to k, which is a given constant. So let's see what we can do here. I'll first of all explain 1 2 3 2 1 1 2 3 2 1 3 1 2 3 1. Okay. So let's see what we can do here. If we keep a dictionary of these two numbers, right? Now we want I and j, such that I and j have distinct values. Now I and j will be values of every of the index at which each integer in this nums array appears, right? So one could be at I here, I equal to 0, right? And j could also be here, j equal to 0. This is totally fine. As long as they are not at the same position, we can actually do this. So what do we do in this case? So we can first of all get so all we need to do is to actually understand that we are trying to look for duplicates, and once we find a duplicate, we need to we need to go further to verify that this is actually a duplicate by finding out if the absolute value of their difference, that is j and I, is less or equal to k. So k here is equal to, hold on, let me bring this back here. K should be equal to k should be equal to 3. So we have 3 here. K is equal to 3. Now we want to find so here is what I said. We'll create a dictionary of each integer in the array. So we'll have 1 here, 1 at index 1, 2 at index, 1 at index 0, 2 at index 1, 3 at index 2, and 1 at index 3. Okay, so the next thing we need to do is, we'll first of all get, we'll say this is probably I and this is J, right? Or any number is J, sorry. This is, you know what? Okay. So let's continue. Hold on. Let's continue. Um, we can choose every value here, right? What have I done? Sorry, I just added 1 there, which is funny. I'm not supposed to do that, right? Because we are trying to build up the map gradually. So that was a mistake. I really apologize for that. So here's what we need to do. We start with 1, right? 1 will be at index 0. First of all, 1 here, we can use 1, and we want I and J, right? So the next number is going to be any number in the array aside from this one. So it could be, from 2 to 3, or 2 to 1, sorry, including 3. So all we need to know is that we are looking for a duplicate, and I showed before that to find the duplicate we need to create a dictionary, right? And once we see the duplicate, what we will do next is to find out if I and J are actually I minus J minus I is actually less than or equal to K. So here's what I need to do. Okay, I found out. So 1 is here. Sorry. We have 1 at index 0. Now this 0 here, right, we can call it our J or I, right? Or let me see, this is I. So the index where the duplication happened, or where the duplicate happened, will be our J, right? And J will be inside this array here, right? J will be somewhere here. So I at 0, right? So this will be the value of I. Okay. So once we add a value in the map, so I call this map X. So once we add the value in the map X, we add the value with the index at which we found it, so that we'll be able to go back and compare, right, if that index actually matches the value that we are seeing currently in the array. So in this case, we'll have 2 corresponding to 1, 3 corresponding to 2, but then we can't do 1 corresponding to 4, right? That's not really possible. So we do 3 corresponding to 2. Okay. Now when we iterate through this array, right, we know 2 is here, and the next value, so the place where the duplicate happened, right, is this one here, where 1 is equal to 4. So that's where the duplicate happened. So what we need to do is to take the index at which the duplicate happened, right? So this will be at index 3, and then we'll find out the absolute value of this. This will be at index 3, so this is index 0, 1, 2, and 3. So this will be 0 minus 3, or 3 minus 0. The absolute value of this will be positive, which is 3, right? So let's see. Contains duplicate 2. So now we know that 3 is less or equal to 3. So which makes this true. So this is true for what it is now. So steps to solving this question. Let's solve this question first of all. Let's write out the code and see what we get from this, and then we can then go ahead and write a note for it. So uh oh my god, I have contains duplicate to 219. Okay, 219. Hey, Code Lifey again. Welcome back. I started not quite. It's been 40 minutes since I started. Wow, I didn't know that. Anyways, you're welcome. You're welcome again. Um, I hope you have been studying and solving lit code questions as well. Is this number 271? Contains duplicate 2, should be 271, right? 219, 219, 219, 219 dash contains dash duplicate dash 2. Oh, let's just do it this way. Rep 1. Hold on, give me a minute. I need to wash my face. I'm getting sleepy. Ooh, I didn't even wash my face. I just went there to jump up and down. Uh that's very funny. Anyways, um, so we created this file and let's solve the question here. So contains duplicate 2. I've already solved this question, but I'm just solving it again. And I will advise that I've repeated that like 50 times already. So I mean, I just want, you know, um, repetition is really good. It's good for, you know, your muscle memory and so on. Anyways, so we have contains duplicate 2. So here's what we need to do. We can say we are looking for duplicates, meaning we are looking for items at um distinct indexes but that have the same values, right? So I'll call this again. I'll say my dictionary and set this to an empty dictionary. Now I will iterate through the values and add each one of them to the dictionary here. So here's what I need to do. I'll say for num in nums, right? These are like very, very similar questions. For num in nums, right? We can say I want to think. So we add the value to the dictionary. So if num not in dictionary, in my dictionary, right? If the number is not there, we add it for the very first time with alongside its index. So you know what? This is not it. We can just do range. Wait, if we do enumerate, right? Can pass it this value, and then we'll have the key value pair, right? I just want to confirm that. Let me see. Enumerate. So for I okay, I'll say key value pairs, right? So in um not range but enumerate of 3 1 like this. So the keys will return the indexes, so the value will return the value. Okay, so key value. Uh, I just wanted to be sure that I was doing the right thing. So we have key, which is the DOM, and the value. You know what? I'll call this index, index, and then value here. So if the number is not in the dictionary, we'll add it to the dictionary by simply doing my dictionary. Sorry, my dictionary at num. Sorry, my eyes are like really going down. Okay, so I was using val, not num. I just I don't want to put pepper in my eyes, so just give me a minute. Uh a minute again. Hello, I'm back. I was sleeping, but anyways, my eyes are clear now. Ah, mm. Hello, son. So, okay, I don't know how to pronounce your name. Hello, you're welcome. Hi, hi, Emmanuel. Yeah, thank you very much. All right, so let's continue. Oh, okay, so I did something here. I don't know what I was doing. But okay, I was trying to get key value pair. So if I do this, I'll get the keys. So this will be 0, 1, 2, 3. Right. So these are the indexes. Let me remove this. So I can close this. So this will be index and this will be the value. So I want, if the value is not in the dictionary, then I'll add the value to the dictionary. And then I'll set the position at which it is, right? So I mean, this doesn't really matter, but we need the index. Yes, exactly. We need the index IDX for index because we are going to use this to calculate if that particular value, the difference between. So this will be I and J, I minus J. You know what? Instead of calling it IDX, I'll call it like I, and I was just set it to I. Right? Okay. So this will be I, the value as I. So if value as I is if the value is not in the dictionary, we'll add it with its index, right? Otherwise, if it's already in the dictionary, right, it means it's a duplicate this time around. So we want to get that particular value and the J. So okay, so I'll call this. I want to make sure that we are using I and J as our variables, right? So that it is not so confusing. But anyways, we store the value in the dictionary. Otherwise, if the value is already in the dictionary else, right, we can then see, we can say if the value in the dictionary um my dict of this particular value, right? This will return this will return the J. So I can store this here, I call it a J. So let's say J is equal to this, right? So this will be our J. This is the index at which, let me close this, sorry. This is the index at which the value was stored in the dictionary, right? Previously I. So since we are iterating through the array, this will just help us store the values, right? So I can say if J, right, the absolute value, sorry, um ABS, I think we have ABS, yes. ABS of is it I minus J or J minus I? I don't know. Either way, ABS will return the absolute value, right? So we just say I minus J is less or equal to K. And we'll just return true, right? Somebody's Free Fire says I'm new here. Hello, you're welcome. Welcome to the stream. Um, we still have more time today, so everybody should should just join in. You're welcome. So, um, here we just first of all we are storing every unique value in the dictionary. But if we'd already seen a value before, right? Meaning if we had already stored this value in the dictionary, we'll check if that value. So I'm just creating assigning J to the variable, right? So if that variable, the absolute value of their difference between this I here and J, which was the previous occurrence of the same value in the dictionary, if their absolute value is less than K, then we'll return true. Otherwise, when all of this is done, when this entire iteration is done, we can just return false. So say return false, right? So meaning we did not find any duplicate. So let's see how this will play out. We'll run this in lit code, right? Don't worry, I'll write out every trick to solving most of the questions that are, um, you know, that have like very similar steps, right? So let's run this and see. Now this is a wrong answer. So what went wrong here? So here this is true and this is false because of something. We say I ij. So we have index at I and the k is 1, right? Okay, so if we stored every value here, hmm, yeah, okay, okay. Dun, 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 dun. So the issue here is that so we are storing every distinct value in the dictionary, right? So meaning I'd already stored this and that. So I would do when I see this the next time, I already know the index of at which it is. So this would be 2 and this would be 0. So 0 minus 2. Oh yeah, 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 yeah. Wait. Norm at I has to be equal to norm at J, which means there's a duplicate, right? Mm, okay. Would it be nice to update the index of the diction of the would it be okay to update the index of the integer in the dictionary? Because this time around we have 1111, right? So if this is not less or equal to k, then we can change this back to here, right? So this time around we'll update the index at which this is. So this will no longer be 1, this will no longer be 0, right? We'll point it back to this, so this will become 1 2 2, and then this will be 3. So here's what I'll do. I'll say if this, otherwise, else. I can just update this here. Else, um else we'll just say, um you know, the value here, we just update this to the current index. All right, it means we found a duplicate, but that duplicate is not what we were looking for, so we need to update it. Let's see what will happen. Okay, now you can see we've passed all test cases, which is good, right? So anyways, this is awesome. And yeah, I'd solved this question before, right? And I probably use some, similar method. Let me just copy this. Let's see what I did previously. So, uh-huh. I mean, it's almost the same thing, right? So here, I'm just calculating. Yeah, so if it's not in there, just add it. You know what? Let me submit this and compare. So we have 45%, 45% in terms of runtime. Now you see, this time around is more improved, which is 80%, right? Now, in terms of space, the reason why this is not well optimized, I think this is because I'm creating a dictionary here, and I'm pretty sure dictionary set and arrays will take space, right? So, yeah, so in terms of time complexity, this will be O of n, and in terms of space complexity, um, O of n as well, right? Because we are storing each integer into the dictionary if it's not a duplicate yet. So, um, that's right. That's right. So let's carry on with something else. Um, so Now there is a trick. I need to take a note of certain things. This contains duplicate 2 and 1 have something in common, but we'll come to that later on. Now there's contains duplicates 3, which is a hard question. I'm not sure if I can solve this question, but let me read it and see. So you are given an integer array nums and 2 integer index diff. Okay. And value diff. Find a pair of indexes, right, such that I is not equal to j. The absolute value of their difference is less or equal to diff. The absolute value of nums at I minus nums at j is less or equal to the value, and return true if such pair exists. Okay. Based on the two previous questions we solved, right? Let's see how we can solve this one. This has like a 22% acceptance rate, which means it's either very difficult question or just annoying, right? Well, we can just give it a try. So, contains duplicate 3. You are given an integer array nums and 2 integers index and diff. Now, from contains duplicate 2, right, we are given an integer. We are given a value, right, which is k previously. So this will be 2. Sorry, I will attend to every question. Just please hold on. Let me explain. Right, I'm trying to solve this question right now. I will attend to all your questions. So please be patient. Okay. All right. So let's go back to the question. Um. So we have we are given this time around. We are given 3 variables, right, or 3 inputs. Before we had 2. Now, if we were able to get this, so we knew we did this as part of question 1, right? No, find duplicate 2. Sorry. In this case, we are given I and j. There will be at I norm at I should be equal to norm at j, and the absolute value of their difference should be less than less or equal to k. Now this time around, let's just say index diff, right, is k. Okay. Now value diff is the new thing that is being introduced now. So the absolute value of the differences, now this case here is k. This will be the actual value, right? I is already not equal to j, which is good. So how do we do this? I can solve this part. So the next part is to use the actual value from the array, right? And the actual value from the array will be the index at I, which will be the index at which we store that value in the dictionary. So we can still use the dictionary here, right? I'm just thinking about it. So if these 3 conditions are true, right, then we can return true or false if not. So let's take a look at some edge cases. So the value diff here will be at least 0, and index diff will be at least 1. Okay, there are not many crazy inputs here, but let's see what we can do. So I'll copy this. You know what, let's create a file contains duplicate 2, which is hard. So this will be in arrays. I'm just using my own intuition to try this out. So I'll say lit What data structure is this question? This is lit code. It's array related questions, right? Oh, there's array, there's sorting, there's sliding window. Hmm, that's interesting. Sliding window. You know what? Let's put it in array first. So this will be lit code number 210 lit dash 220 dash contains duplicate. I'm just attempting this question. I don't know if I'll solve it, but in the case where I solve it, then that's good, right? Contain duplicate 3 for the very first time. I'm attempting a difficult question. I'm not attempting it to, you know. Oh, let's see. Okay, I can import this. Wow, this is a long input. But okay, so here's what I would need to do. I'll first of all create a dictionary, right? You know what? Let me come here. Let me go to the board, right? And we still have the same input, but now we have index diff, value diff. So here, let's see how we can do this so that we return true. So I'll remove everything here. Index diff and value diff. So index diff will be 3, right? Hope they choose 3. Okay, 3 and the value diff is 0. So we have um, index diff, which is 3, and then value diff, which is 0. Now, we know how to find index diff, right? We store the value in the dictionary, which will be, um, this will be 0, the value and its corresponding index. So 1 is at index 0, 2 will be at index 1, 3 will be at index 2, and then there is 1 now. So we can check if 1 is already in the dictionary. Now, yes, 1 is already in the dictionary. At what position is 1? 1 is at position at index 0, right? Its previous occurrence was at index 0. So this will be, we'll take that index, which is 0, and the current index here, right? I'll call this I. This will be equal to 3, because we start counting from 0, right? We start counting 0, 1, 2, and then 3. So we'll do 0 minus 3. The absolute value of this will be equal to 3, and 3 is less or equal to 3, which is true. So we'll find the index diff like this. With this method, we've already found out how we can get the index diff. Now, the value difference, how do we get the value difference? Now, so we've done 2 out of 3, right? So far we've done 2 out of 3 steps. We know how to get the distinct items, right? Such that we know where the duplicate happened and how to avoid the duplicate and so on. Now, the next thing we need to do is to find out if the difference of those two values, right, is equal to 0. Obviously, that is going to be, index at 1, right? So I'll say num at 1. So how do we get nums at 1 here? Well, it's already in the dictionary, right? We can even get it with this. So we'll say 1 minus 1, right? 1 minus 1 is equal to 0. So 0 is less or equal to value diff, which is equal to 0, right? So that's what we need to do, right? That's exactly what we need to do. But this part here in the previous question I solved, right? This part here, instead of doing it this way, right? okay, you know what? So if the absolute difference between these two is less or equal to k, then we return true, right? Else, if it's not, we'll then, so this, I forgot to put this. Else, else we can just say this, right? But there's another way we can simply write this. We can say, um if the absolute value of their difference is superior to k, we'll do this, else we return true, right? That will work. Let's see. If the absolute value of this is superior to k, right, we can do this. We can just do this. I mean, it's still the same thing, right? Else return true. Return true. This will still work. This is just the same thing as what I did before. I mean, this doesn't change anything, but you know what? It will be easier for someone to actually understand this than the other one. So we know if the difference here is less than k, we return true, otherwise we do this. Now, there's another thing that will be introduced. So let's write the same code here. I'll create my dictionary. I'll call this my dictionary, and then I'll set this to be equal to an empty dictionary. I'll say for num in, so we want to use enumerate, so I'll say I, right, I and value. In enumerate, we enumerate the nums array, and we'll say if the value is not in the dictionary, right? If value is not in the dictionary, then we add it to the dictionary. So we say my dictionary at this value here be equal to the index at which it occurred. So we really need this. Else, so this is where we check for other stuff. So I'll just set this as j so that we know we are using I and j, right? So else this will be, j is going to be equal to this, the current duplicate that we found, right? And then we'll say if I, the absolute value, so abs of I minus j, right, is less or equal to the index diff, I and j will return the index diff, right? So index diff, and, right, and value, sorry, and I'll just do this, and you know what, I'll call this, I'll say I will just do I minus j here, the number at I minus j, or you know what, I can just put it in the same line. I'll say nums at or I can say the current value, right? Right, val minus so we'll get to get the value at dict, right? So we can just do, is it the absolute value we are searching for? Okay, the absolute value. Okay, so we say this will return the current value, right? Say abs of the current value minus nums at j. Now j will return an index, right? Remember, j will return an index, and we'll use that index here. if this is less or equal to value diff, right? Value diff, then we return true. Otherwise, else we just return. Oh, so we don't return anything yet. We can switch the position, the index, right? So we can say set this to the next index. So where the duplicate is, and that's all we need to do. So I can just return. Otherwise, if we don't get anything, then this is false. So let's test this out. So I'll say solution, my solution. My solution is going to be equal to the solution class, and let's print my solution dot contains duplicates. First of all, the array we are using is going to be, I remember, is 1 2 3 1 1, and the next one we have index diff is 3. The next thing is value diff, which is equal to 0. Okay, so this should return true. Now we have true here, which is true. So let's test this out to see if we pass other test cases as well. So I'll copy this and try it out in this place. Even though this question might pass the test cases, I'm so sure there's something wrong with this question. For 1 million people to submit and 255 people to get accepted, there is something wrong with this question. But let's see, value diff is less or equal to 0. The test cases here. Anyways, let's see if we pass the test cases. I hope. Oh, there's no error. Let's see. I just do it. Something might be wrong. Something might go wrong somewhere. Anyway, so let's see what happened. Value diff here is 1. Index here is 2. So with index value diff is 3. Index diff is 1. So let's see, 1 8 7 15 1. Okay, so we have 8 and 7. That's 0 1. Okay, you know what, let's copy this. I would like to try this out. Okay, so here's our input, and we did this. So let's create our map. So we have 8 at index 1, index 0, 7. You know what, let's do it this way. I'll do it here. 8 at index 0, 7 at index 1, 15. I can even write them here, right? Okay, you know what, let me just do it like this. 15 at index 2, 1 at index 3, 6 at index 4, and then we have 1 again, right? This will be 5 6 7. So we have a duplicate here. So the previous occurrence of this here is at position 3, index 3. So let's find the difference between the two indexes. So this will be 3 minus 5, right? 3 minus 5 is what? Is 2. What is our k? And index diff should be 1, and value diff should be 3. So I'll say val diff vd, right, is 3 Index diff is 1. So here already, this is wrong, right? This index difference here uh, is already less, more than. Uh, I mean, we are putting the absolute value, which is why I did put -2, so it's equal to 2. Anyways, 2 is superior to the index diff, right? So, wait, if nah, value diff is 3. How? How can value diff be 3? Wait, is there something else I didn't read here? Is there something else that I didn't read? Let me duplicate this, please. Because the question says, um, I see why this question is now difficult. I mean, we want, yes, okay, should be less or equal to the value diff, right? Value diff is 3. Okay, that's good. Value diff is 3. So, whatever we get should be less or equal to it. So let's see. This should be, so since this did not work, right? The difference here, we'll look at the next difference. So this will be 7, index 7, and what's this here? 2, right? So do 7 minus 2 again, right? 7 minus 2 is equal to 5. So 5 is still superior to the index difference here. So what's going on? uh, I mean, ideally, we don't have any. Uh, we don't have any solution. That's what we are saying. But this is supposed to return true, and we are returning false. I don't know what's going on here. What's going on? What's happening? Let me check the chat if there are. Hello, hello. Let's see. Let me respond to some chat. Yeah. So some please advise me your videos which are VS Code for beginners. VS Code is a tool for writing code. So, what you really want to do is learn a programming language and then start using VS Code to program something you really want to build. Yes. So, I don't have a video on VS Code, but you can look online. Um, if you know a programming language, then basically you can write any language in VS Code. At least I think. Yes. So, thank you. Some said yes. Thank you very much. Thank you very much. Yes, Rohit, I remember you. I remember you from. It's been a while. Nice to have you back. All right, so let's continue with the question. How many more minutes do we have left? Oh, there's more time. There's a little bit of time. Let me refresh my screen. Dun, 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 dun. Dun, 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 dun. You guys are awesome. Thank you for turning up. All right. So what went wrong here? What went wrong? I mean, we can't have the same value at. I mean, two different values at the same index. That's not possible. One integer has to occupy exactly one index, right? So I'm just trying to see what we should do here. You know what? Is there an editorial for this? Subscribe. How much is subscription? Jesus. No need to look. Okay, so uh obviously let's see some solutions here. Do we do we need to sort the array first? Okay, you know what? Before I look at the solution, right, let's take a look at some hints. This is also helpful. Oh no, time complexity O n log k. This will give an indication that that sorting is involved for k elements. Ah, I see. So we needed to sort the array. Use already existing state to evaluate the next state, like a set of k sorted numbers are only needed to be tracked when we are processing the next number in array. So wait, when we are processing the next number in array, then we can utilize the existing sorted state, and it is not necessary to sort the next overlapping state set of k numbers again. Does anyone have an idea what that means? Because I don't know what I just read. Ah, okay. You know, just being cheeky, right? Let's see if I did this nums dot sort, sorry, dot sort, right? What do you think will happen? Exactly. I thought so too. This will be wrong. Because after the norms are sorted, then the indexes change, right? Which means we'll find quicker values than we are supposed to. You know what? Let's take a look at some solutions and see what is happening there. Sorry, I don't have the money now. Uh okay, so here's what I'll do. I'll say uh, mm, so I saw this, yes, so here is it. So this is a very self-consistent series, although ad hoc implementation exists. Please check corresponding posts in discuss their solution bear great resemblance to each other. So contains duplicates, which is the first one. I've already solved this one. So yeah, we've done this. Contains duplicate 2. Progressing to contains duplicate, extra info needed. So um again, same thing I did. So this is short-handed, but anyways, it's still similar stuff. Same thing, right? We know if this isn't, then we set the value to the dictionary. Coming back to this problem, we can summarize numbers in a given range into buckets. By bucketing numbers properly, this becomes almost identical to 219 contains duplicates except that numbers in adjacent buckets need to be checked as well. Hmm. What does that mean? So return t if t is equal to s or equal to 0. What's this? What is this? Okay, we change it to t. Contains nearby almost duplicates. Hmm. Sin is equal to this x I in enumerate norms. The bucket is equal to x. Now, if bucket is in sin and I, which is the current index minus sin bucket sin bucket at 0. I don't understand this. I might have to, properly process this very well. Um, well, I'll look at it later. So I'll add that to my list. Uh, let's solve another. I was actually planning to do sliding window questions today, and somehow I found myself, you know, only doing some part of the things that I have planned. So let me solve one more sliding window question, then we can call it a day. Right, 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 right. That question was just. I'm not sure why. If I want to spend time, figuring it out, I'll have to like, you know, waste a lot of time, and I don't want to do that here. So I'll just keep it simple and allow people to enjoy the session, this stream. Okay, so let's do one more question. Then we call it a day. So, given an array integers norms and an array, so I need to write a note. Sorry, I forgot. There needs to be a note for questions like this. Uh, contains duplicates, finding duplicates, right? Um, you know what? Let me do this. Git add git git commit dash m contains duplicates. Sorry, it's an array question. So array lit code dash 219, right? No, I'm not doing 219. I'm doing this. Okay, 219 and what? It's just 219. Okay, 219. Oh, I should have excluded this. I already added it, so don't worry. I even do 220. I didn't even see it. I thought it was, yeah, 220. It was 220. I needed to avoid. Okay, so let's keep this out of here. Let's talk about this, but let's take a note for the previous question we just solved. Um, so I'll put in here, right? So I can say finding duplicate. This won't be a folder. Sorry, let me delete this. Delete. Don't ask again. Just delete it. I knew before I said it. So I can put in here. Yes. Um, a minute, please. I'll be back. I come. I come. I am back. So we need to take a quick note. I want to write out something quickly. We'll write a note on how to, treat duplicates, how to solve duplicate related questions, right? So, um, so when a question involves finding duplicates, right? Um, one of the major things I mean, one of the things that comes up is to use to use dictionaries, right? So we can use, with the help of dictionaries, we can get, you know, a previous value, because we can add the same keys in a dictionary, right? Duplicate keys in a dictionary. So we can either use a set or a dictionary to keep track of duplicate values. So I would say solving. I'm not sure if I can solving. Okay, you know what? Let's just say duplicate 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 values. Okay, let's call it duplicate values. All right. Okay. So duplicate values algorithm. So we can say um so Uzbek said hold on, best one. Okay, you're looking for the best uh IDE, right? I'm not can you rephrase your question again so that I can answer you properly? All right, so let's see. Oh, my lesson, the best one. I'm not sure I can choose anyone which is the best. That is just going to be your own opinion. So just find whatever you want to learn, right? Just let me know, and I can actually point you if I have a video on it, or if there is any resources out there for you to look at. So what to do when asked to find the duplicates in a data set, right? I can call this iterable. Iterable, like this. So here is this. We'll first of all create a dictionary. So I'll put, okay. So create a dictionary, a, come on, create a dictionary to keep track, to a dictionary or a set, right? Let's use that. Or a set. What am I doing? Or a set. Or a set to keep track of values previously 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 seen. We can also to keep track of values previously seen, right? So iterate iterate through the list or array. Come on, iterate through the list or array and add the hold on and add the values of the array as keys to the dictionary or to the dictionary like this. Come on, we are not here yet. Come on. Okay. Uh, if the value in the current iteration um, exists in the dictionary, then a duplicate has occurred. A duplicate is found, and the iteration needs to be terminated like this. So I can put some questions here. I'll say useful questions you can find. So I'll put it here. Say useful question for this related questions. Okay, let's just put like this. So we can put some questions here. I'll copy some few questions we have here. So this will be lit code 24 contains duplicate 1. I just want to do this first. Yep. So we can do this. Contains duplicates 217. We can do 219. So there is this thing you can do in Markdown. You just put a square and then you can say 219, right? Dot contains duplicate 2 I and just do this. So you put the link here. Okay, so this will automatically so you can see the questions are here. So this will also help us to know exactly which questions we should practice where we are studying um where we are studying a particular data structure. All right. So I can even add some code snippets here. 4, 5. What's that? Duplicate. Hmm. I can copy some part of my code and then put it here, right? So it's 217, right? Question 217. 217. Okay, so I can copy this part. Okay, I needed to do this. I think I can do this as say pi, right? And then put this here. Hold on, I've forgotten. Mm, Anybody knows how to use Markdown here? Um, how do you do this? I think you put. Okay, this is not what I was planning to do. Um, you know what? Let's just do insert code block. Oh yes, and you can put the language there. I see. So this will be pi, like this. Yeah, so it's Python, so it's there. Okay, this is good. This is good. All right, so this will be useful for reading and understanding what's going on. What I wanted to explain was sliding window. So the sliding window algorithm. So here we can here are a few examples. Well, the best example to use to explain something like this. So it says if I'll not immediately give the examples here, but instead I will just I can write this after this stream today, right? Um yes, I remember you. I remember you. Okay. Oh my god. So, I don't know if I can push this to GitHub because I would really love to share this with you guys, but I'll find a way to share it on GitHub as well. So I'll write out every note, right? I was planning to do this here, but honestly, my time is up. Uh, and I need to go now. Um, hopefully, hopefully I continue. So tomorrow is still weekend, so we'll do more tomorrow. Um, Uzbek, thank you very much. Thank you very much. Um, yes, there's 5 minutes left, right? Okay. I think I should. What should I do with the remaining 5 minutes? You know what? Let me explain this question. Let's see. Let's look at this question here. This is really fun, right? Uh, let's take a look at this question. Ouch. So sub array product less than k. So this is a sliding window related problem, and it is quite interesting how this problem is really related to the maximum sub array sum question. But I'm not sure if the maximum sub array sum question is here. This is product. I want maximum sub array sum. Anyways, you know what? Let's read this question. I solved this question previously, and I still, thankfully, I still remember how I did it. So here we are given an array of integer terms and an integer k. Return the number of contiguous sub arrays where the product of all elements in the sub array is less than k. So we have our input here, which is num, an array of integers, which is 10, 5, 2, and 6. And we want to return an array of contiguous elements, right? We want to return the number of contiguous sub-arrays such that the items in that sub-array are less, the product of those items is less than k, which is 100 in this case. So here is what we need to do. First of all, we need to understand what a sub-array is, right? A sub-array is simply a subset of a larger array, right? So it could be anything in that array, 1 item, 2 items, 3, it doesn't really matter, as long as it is part or it's a subset of the larger array, then we know for sure that this is a subset. So first of all, let's see how we can do this. So here is our input, right? And we are given some integers in this array. So we have this. So here's what we need to do for this first. Each one of these, right? One thing we need to know, as long as the item in the array is less than this here, right, which is 100, which is k, right, we know for sure that already is a sub array. So 10 here is a sub array of this array x here. Let me call this x. You know what? Let's call it num, as it was called before, nums. So 10, nums is equal to, so we have 10 first of all, we have 5, we have 2, we have 6. All of these are sub arrays of this DOM array here, right? All of these are sub arrays. So we want the contiguous sub arrays such that the product of their items is less or equal to k. So in this first sub array here, the products of these items, so we don't have more than one here, so this is literally less than k, right? So the first condition has been passed for this sub array. So far we have 4 sub arrays now. Now let's find out how many more sub arrays we can find. So if we go from here to here, right, this is our first sub array, right? So this is 10 and 5. So if you do 10 times 5, this will be equal to 50. So 50 is a subset, or 50 is less than k, right? So our sub array so far will be 10 and 5, right? So let's see how far we can go to include more items in this case. So when we move from here, we can include 2, right? We are not given any specific amount of items that our sub arrays should have, right? So we can go as long as, the entire array. So let's reach here. So in this case, we'll have 10 times 5 times 2. This is equal to 100. And we want the items to be less than k, right? Strictly less than k. Strictly less than k. So this is 100. This is not less than k. This is equal to k. So we stop at this point. So our next sub array will be this. So we'll remove 10 and then we'll continue from 5 to 2. 5 times 2 is 10. So we have our next sub array is 5 and 2. Then we move to the next one here. 10 times 6, this is 60, right? So we add 6 to this place and we stop here. So when we count this, this will be 1, 2, 3, 4, 5, 6. So we have 6 items so far. Now that's not just all, right? Because we have more items we can pair in this array, right? So what do we do next? We have 5, 2, 6. Okay, I've done that. Um let's see, how many did I get here? 8. And we have 6 here. So it's remaining 2 more to go. Um so there is 10, 5, 2. We have 10, 5, 2 here. Okay, okay. Um 4, 6. Hmm. I was thinking, hold on. What's the question saying? The total amount, right, of items we have where the product is less than K. Okay. So, I mean, after finding 10, I mean, we still have 2 and 6, right? And we have 5 and 2 as well. So, we can do 5 and 2. Sorry, I forgot to even include it here like this. But, anyways, we have 5 and 2. We can go to 2 and 6 as well. 2 and 6. So this will be 8 items in total. I will explain this, in details tomorrow. My time is up now, and it was lovely, recording this stream today. Thank you guys for coming through. Thank you, everybody in the chat section. Thank you, Uzbek. Thank you to everybody who stayed throughout the stream. Um, I'll see you guys tomorrow, and I will explain this question in details, and I will give more examples, and we will solve some other related questions as well. And I plan to keep taking notes in Obsidian and share that with you guys so that you can read through and then see some useful ways to do certain things, right? All right, thank you guys, and bye. Sorry, I think I did not push this to GitHub, so let's quickly push this part to GitHub, this question here. So I'll say git push origin main. All right, okay, that's it. We are done for the day. You guys should go and rest and continue studying and stay coding. Bye.